on...
My name is Martin Moeller. I'm Senior Curator here at the National Building Museum. Thank you very much for coming. I'm also curator of the Secret Cities exhibition, which I hope all of you have had a chance to see, which is the connection, of course, to tonight's program. For those of you who may be new to the National Building Museum, we are a unique institution dedicated to all aspects of what we call the built environment. So that's architecture, engineering, construction, urban planning, preservation, landscape architecture. Anything you put on the planet, we'll talk about it. And it's a very broad mission, but as I say, unique, because there are lots of other museums that address aspects of that, but not the whole package in the same way that we do. And actually, the Secret Cities exhibition is exemplary of that sort of thing, because we talk a bit about all of those disciplines, but we also talk about their impact on people. We don't present these things just as isolated endeavors, but they do all have an impact on people's daily lives, as is evident in the Secret Cities exhibition, and that'll be implicit in much of the conversation tonight. A couple of things that I do want to mention. The exhibition has actually been extended. Its run is now going until, I'm sorry, I don't have the exact date, but I believe it's now going to be up until June. So we've already had 60,000 people come through the exhibition. Wow. We would greatly appreciate your letting people know about it and have more of them come. I will also want to mention that we are a private nonprofit institution, and that means that we have to raise every dollar for everything we do, and we are very, very grateful to the sponsors who've made this exhibition possible, which include, not coincidentally, Bechtel. Speaking of that, in 1998, the year that I started at the National Building Museum, I was 3 years old, thanks for asking, was the year that we honored Bechtel for, I believe it's technically its centennial at that point, as with our honor award, and a great big event that also included an exhibition about the firm's work from the Hoover Dam on up to work of the present. So we have a long-standing relationship with Bechtel that we really treasure. Tonight we're here to discuss the current and future situations of Los Alamos, Hanford / Richland, and Oak Ridge, the three secret cities that are featured in this exhibition. Now 75 years after all that was going on, which is kind of hard to believe, and to talk about where they're headed, what's still going on. As I was developing this exhibition, a lot of people were surprised to discover that the secret cities still existed. They thought they went away with the end of the war. Now obviously, we all know that a great deal of important work is happening there, and that just as was the case with the Manhattan Project, architects and engineers and builders are critical to providing places for that work to happen. So tonight, to help us tell this story, we're joined by several people. First, the Honorable Lisa Gordon Haggerty, who serves as the Undersecretary for Nuclear Security of the U.S. Department of Energy and Administrator of the National Nuclear Security Administration, NNSA. For those of you who aren't in the know, you're going to be hearing those initials a lot tonight. She has an incredibly impressive resume, more than 30 years of national security experience under administrations of both parties on Capitol Hill, and I was interested to learn that her first job was as health physicist at the Lawrence Livermore National Laboratory. NNSA, through its national laboratories and plants, maintains and enhances the safety, security, and effectiveness of the U.S. nuclear weapons stockpile. The continued success of these laboratories and facilities, the ones that began as the secret cities, are vital to this mission today and for the next 75 years and beyond, surely. We're also joined by David Klaus. He has spent decades working in both the executive branch and on Capitol Hill. During his tenure, David led the office of the Undersecretary for Management and Performance at the Department of Energy and served as the Chief Operating Officer and also oversaw the Office of Environmental Management. Currently, he is a William J. Perry Fellow at the Center for International Security and Cooperation at Stanford University and works independently to develop public policy projects on energy-related issues. Additionally, David has been a leader in historic preservation of the Manhattan Project legacy, having designated the, quote, signature sites of the Manhattan Project in 1999 and helped lead DOE's initial establishment of the Manhattan Project National Historical Park, which we talk about in the exhibition. And finally, we have Peggy McCullough, who is Bechtel's Senior Vice President and General Manager of Nuclear Security and Operations. In her current role, she's responsible for Bechtel's overall management of nuclear security sites, including the Secret Cities location at Oak Ridge, Tennessee. She's also very familiar with the Hanford site, having served as project director for construction of the nation's most complex radioactive waste treatment facility. She also has decades of experience leading complex mega projects in the U.S. and abroad, and today her projects and sites support the DOE's mission to provide modernized and secure facilities, again, for the next 75 years. So now I'm going to sit down, and we're switching over to this, good. So I'm going to begin with a question for Undersecretary Gordon Haggerty. That's a mouthful, but Ms. Manners says that's how we refer to you, and I'm not going to cross Ms. Manners. So 2 of the 3 Manhattan Project sites that are still operating today, and the third is undergoing extensive environmental cleanup. Can you briefly talk about the ongoing missions of Los Alamos National Laboratory and Oak Ridge, the complex, specifically Y12 as we know it today?
Certainly. First of all, though, David, I would like to thank you for this unbelievable opportunity for the Secret Cities project. I know it's near and dear to your heart and to many of us. And in fact, I've already made a note that I'm bringing my husband and my family back because this is really incredible. So hopefully we'll be able to double that 60,000 and bring another 60,000 in because it's well-deserved.
Thank you.
I'd like to say that. Second of all, I'd like to recognize that former Deputy Secretary of Energy, T.J. Gauthier, who's joining us tonight. So it's an honor and a pleasure to see you again, too. So with that, with regard to the secret cities, and we've seen 3 sites this evening. One of the things I'd like to say is that having the awesome responsibility as the administrator of the National Nuclear Security Administration, I'm fortunate enough to be responsible for 8 labs, plants, and sites, 2 of which are Y12 or Oak Ridge in Oak Ridge, Tennessee, and the second one being Los Alamos National Laboratory, both of which are obviously having their 75th anniversary today. They are very much alive and well, and I anticipate long after I'm gone, they will be around for 75 more years. Los Alamos continues to be started out as our facility for our nuclear weapons design, as everyone knows, and it's got a long and rich history. It continues to be our plutonium center of excellence. It continues to be one of our 2 nuclear weapon design agencies, the other of which is Lawrence Livermore National Laboratory in the East Bay of California. And it has a long and rich history. It's going to continue. We are putting billions of dollars into the infrastructure to keep Los Alamos in play because it's such an important part of our nuclear weapons stockpile and maintaining our nuclear deterrent. At Y12, the plant that we saw at Oak Ridge, we undertake all uranium operations there. So nuclear weapons and the military application have 2 components, and the work that they've done in uranium continues today. And so we are building that up, and we're very proud of the work that's been done there. We're refurbishing and removing facilities and recapitalizing efforts there. Some of the facilities, David, that I think is interesting to point out is these are 75-year-old facilities or 75-year-old sites. There are facilities that we are operating that were built 75 years ago, and we have recapitalized those buildings. Many of them have been torn down, but of note, more than 50% of our facilities throughout the NNSA complex are more than 40 years old, and 30% of them were built in the Manhattan Project age. And our workforce continues to work around, find ways to improve and to maintain our nuclear weapons stockpile and our national security. So those are just 2 of the 8 sites that we operate, but it's very impressive, and I'm looking forward to helping put them in place and keep them operating so that we'll have maintaining our nuclear deterrent for 75 years and beyond.
I'm always amazed by the longevity of some of these things. It reminds me, as many people know, that B-52s are still in our arsenal. They're older than I am, and still flying around. It's kind of extraordinary how these things hold up. I do also want to mention, I neglected to mention before, that at the end of our talk here, we'll have opportunities for questions from the audience, and a couple of folks from Bechtel, Tina, and Lexi will be collecting questions on index cards. So if you have a question you want to get writing it down in advance, just check with one of them. David, following up on that, could we talk a bit about Hanford and the cleanup project that's underway there?
Sure, and let me join in thanking you for this exhibit. I think one of the interesting things, if you go to the secret cities and a lot of the DOE facilities, you'll see each of them is very proud of their history and very proud of the role that they played in the Manhattan Project, and each of them has museums. But you've brought it to Washington, yes. And it's so nice that you're able to bring such a great exhibit and have the folks here see all 3 sites and understand them. Hanford is an interesting site. I mean, to understand it, you have to understand it's over 500 square miles. It is fairly massive. You could start from here right now and drive to Baltimore, where you at the site, and you'd still be on the site. So it's that equivalent distance within the site. It is the site where they developed, where basically plutonium was produced, and there were 9 nuclear reactors and a number of production plants, chemical plants, that isolated the plutonium after it went through and was enriched from uranium. Frankly, we made quite a mess. And right now, the U.S. government spends $3 billion a year in Hanford. $2 billion of that goes to the cleanup. About a third of that goes to the waste treatment plant, and Peggy here did a great job of overseeing the construction of that facility for a period of years, and I'll defer to her on that. About the other 2/3 of that $2 billion is involved in taking down some of the most complex, challenging facilities, plutonium finishing plants, all digging up and finding things that were buried, dealing with tunnels that were filled with waste at different times. The U.S. government spends, just to give a perspective of the overall cleanup program, the U.S. government spends about $6 billion, $6 to $7 billion a year. The projection is that we'll be doing that for another 40 to 50 years, and the one place we'll be doing it the longest will be Hanford, because it has 177 tanks ranging from 50,000, I think, to 50,000 gallons to a couple, to larger than that, of toxic radioactive waste. And so the U.S. government's going to probably be spending $2 billion, if not more, for the next, frankly, 40 or 50 years in Hanford. But that's not all of what happens at Hanford. The other $1 billion goes to the Pacific Northwest National Laboratory, which is one of the 17 national laboratories that, in some respects, and I'm glad you're talking about the future, are for the future not just of the Energy Department, but frankly the future of the United States economy and the future of this country, in which they do groundbreaking research in cybersecurity, they do it in environmental issues, they do it in a whole range of different things. And so there's several thousand people who go to work every day at a national laboratory, also in Hanford. Although I should say they don't see themselves as Hanford now, they see themselves as the Tri-Cities, right. And they're quite proud of that. So that's where Hanford is today, and I think even when you finish the cleanup program, I think the investment in the laboratory in the Pacific Northwest, and I guess one of the rare benefits of climate change is that the climate that was in Napa has now kind of moved up to Washington State, and so they have the great wineries. So there's an additional reason to come and visit.
Why don't we pick up on that, Peggy? The mention of the waste treatment plant facility, most people hear those terms and think of something entirely different from what you're familiar with.
That's actually true. Before I went to WTP, I was building a coal mine in central Queensland, Australia, and when I told that customer I was leaving to go to the waste treatment plant, he sort of crinkled his brow and said, "Really?" I said, "It's not that kind of waste."
Right. It's much scarier. It's much scarier.
Yeah. Just picking up on what David said about the challenge of the mission at Hanford, those 177 underground tanks house 56 million gallons of liquid waste. And those 9 reactors and 5 chemical process facilities generated the most voluminous and most complex waste stream in the U.S. So the waste treatment plant is being designed and built to take that waste from what's called those tanks are in a place called the tank farm. Take that waste from the tank farm and separate it into the most highly radioactive and then low-level radioactivity waste. Those facilities then feed that pre-treatment facility then feeds 2 downstream facilities, one for high-level waste, one for low activity, and those are vitrification facilities. So vitrification is a process for immobilizing waste by putting it into a huge melter, and then glass formers and some other chemicals are added. It's heated up, and then that mixture is poured into stainless steel containers to cool, and that's what immobilizes the waste. It's encased in glass, because today, some of those tanks, some of those 177 tanks are leaking and have been leaking for some time. So that complex of facilities at WTP also includes an analytical laboratory, because the facilities operate on a batch philosophy. So before a batch is transferred and after it's transferred, it's sampled And that analytical laboratory, when it goes into full operation, will be the largest in the United States. So the plants, the operating life for the plants is notionally 40 years. So when David talks about and low activity waste, the construction is complete on that facility and it's being commissioned as we speak. And so it's an incredibly important mission. It's important to the people that live in that region that certainly don't want that waste leaking into the groundwater and getting to the Columbia River. So it's just, there are a lot of Bechtel folks here this evening. If you worked on the waste treatment plant, would you raise your hand?
Oh, wow.
Yeah.
Oh, yeah.
So it is an incredibly challenging job because the waste stream is, and the knowledge about what's in those tanks has evolved over the years. So it's a great project, and we're proud to be associated with it. And we need to start making some glass.
Hey, Peggy, could you give them a sense of the scale of what gets produced there? Because I think when you think a container of glass, I mean, how big are they? I mean, I think if you don't understand the scale,
Yeah, they're huge. So the high-level waste canisters are designated for ultimate disposition at the nation's repository, which was formerly going to be Yucca Mountain, yet to be determined. And the low-activity waste logs, they're called, but don't think of like a log in your fireplace. These canisters are huge.
And bigger than the columns outside?
They're not that big.
But they're about as wide, though, aren't they?
Not as wide as the big columns, but those low activity waste logs then will be go for final disposition on the Hanford site.
Let's talk about, you've broached a subject which interestingly came up in my conversations with people as I was developing this exhibition very frequently, which was about the health impacts of this sort of material, the experiences of people who were at site during the war, but also afterwards. And as a curator, as for a scientist, you have to go in and see where the evidence leads you. I didn't find any compelling evidence today of significantly greater health risk in the people who are living around these facilities. But no matter how many times I said that, there are always people, but there's always a but. And I wonder what you folks might be able to contribute to that understanding about the risks to people living near these three sites, which is now hundreds of thousands of people collectively.
Well, I'll try and take a run at that. I think a couple things. One is that you have to understand how long, the length of life of these materials, and that you're preserving them and that you're glassifying them not because you're worried about the next 50 or 100 years, it's the next 100,000 and et cetera years and where they may be. The other is that while the facilities are really quite large, the material is really quite dangerous. And I think plutonium is a very, very, very toxic material. And some of the demolition, there's been a number of halt stops at the facility, not necessarily because it was getting off-site, but actually some of it was getting off-site, but because the workers who are working there are experiencing, at the tank farms, they were getting ventilation issues, sort of issues with toxicity of that. There were some particles of plutonium were finding their way out of into some cars and made potentially off-site. I don't think there has been identified, at least in terms of the Hanford site, although there have been at some of the other sites, there are issues with what they call downwinders, and some of the closed sites. There have been issues, and the department has continued to be extremely concerned about that. And in the past, there was beryllium that was affecting others and the like. So I think historically that's been true, and it's always been a challenge for the department because I would say that during the Manhattan Project and the following years of the Cold War, as much as the focus was on production, and the focus was not on what are the environmental impacts and how do we do this. It was how do we save the world by producing the material, what we need to do that. And so those issues continue, and I'd like to think, as you say, that it's hard to identify specific incidents, but there are a number of issues. There's some issues with some reserve material in St. Louis about in one of the waste sites that's there. So it's a continuing issue, and you continue to deal with it.
And let's just be fair about this, but 75 years ago, we were just learning about, as we unleashed the atom, we were starting to learn more and more and more about working with radioactivity. And as we did, we applied more safety and security factors to it as we were undertaking these projects. So, and we've learned a lot from that.
Right.
But the Department of Energy and other parts of the U.S. government continue to monitor around the different sites and continue to worry about the health of our personnel.
So I would just add, Martin, I mean, having lived at Hanford for 4.5 years, I certainly personally never feared, at all living out in the community. I think the community's quite safe. Both the Department of Energy and the contractors are supremely concerned with the health of their workers because these are very hazardous materials. And so in my last year at WTP, there was a subsidence of a tunnel, which is very close to the WTP site, not on our site. And a bunch of stuff got put in those tunnels, and it got covered up. And it was, it had a wooden roof, and it had been sitting there for many, many years, and there was a hole in the roof. And so our workforce on site was sheltered in place for many hours as the determination was made, is it escaping off site? What is coming out of that hole? So when those things happen, the department and its contractors take it very seriously. And job number one is to protect the workers, but aging infrastructure is an issue. And I think we'll probably talk a little bit more about that. But in terms of the community, I'm not aware that anything has ever gotten out in the Hanford community that the public had to be concerned about. Yeah. The workers, we have to be concerned about them because Absolutely. They come close to these materials.
Sure.
Although I will add that the community has a little bit of a sense of humor about it because it used to be that the restaurant at the airport at the Tri-Cities was the Three-Eyed Fish. So
I didn't know that. That's funny.
But let's pick up on that, as Peggy was saying, going back to really kind of the first comments that the Undersecretary made about the aging infrastructure. I mean, it's impressive on the one hand how well this stuff has held up, but obviously, as we all know, if you own a house, you know about aging infrastructure. Stuff goes wrong, but these are vital facilities, not only in terms of the potential risk to the public, but also in terms of their production, their role in creating implements that we hope will keep us all safe. How are there new strategies for dealing with this? Is it just sort of, you cover up that patch when it happens, or are there longer term things that are now underway to try to deal with that old stuff? Mm-hmm.
Well, sadly, that's what we've been doing for many, many decades, is patching things. Under the new Nuclear Posture Review of 2018, the Trump administration and the U.S. government, supported by Congress, is undertaking a major modernization program across all of the infrastructure throughout the NNSA as well as the Department of Energy. Our people deserve no less to work in safe and secure facilities. We are modernizing and recapitalizing facilities where we've got a plan for the next 25 years or so. As I'd mentioned, we're recapitalizing the plutonium facility at Los Alamos National Laboratory. We're undertaking a massive program, as you're very familiar with, at UPF, or the uranium processing facility at Oak Ridge at Y12. It's a $6.5 billion construction project, and it's going to be completed on time and on schedule and on budget in 2025. That will be replacing facilities that are 75 years old now. We're taking people out of facilities, and I've got to tell you, it's something about the facilities and the infrastructure. It's pretty amazing that our workforce has found the workarounds and the ways to continue to maintain our nuclear deterrent, to reduce global threats, to continue to power the nuclear navy, which is also in our portfolio. And they found the workarounds to work in a safe environment, but to work in facilities that, like I said before, some of which are 75 years old. And so it's about time that we modernize our infrastructure, because in order to do so, that's what we need to do to maintain our national security. And we have undertaken massive projects at Los Alamos and all the other 7 labs, plants, and sites throughout NNSA, and many more throughout the Department of Energy. We've got a long road to hoe, but with the support of Congress, we will continue to do so.
I would just add that that was a big concern during the time that I was at the department, and the Laboratory Operations Board, which was put together, did a study of the infrastructure of the department, and it looked at where it was from the standard, what standard it was at, et cetera. To put it in perspective, since the department has taken down over 3,000 facilities, it has currently about 2,300 facilities, and that can be a small building, it can be a large building, that they would like, frankly, to be gone. And the deferred maintenance figure is in excess, I think it was about $5.4 billion in 2015.
Of which we are $2.5 billion in backlog.
And the problem is that it's the continuing challenge of dealing with the mission, and someone says, well, how do you take care of what happened? And I'm really pleased to hear just what a focus you've had on the infrastructure, because one of the things that the study that we did pointed out was that that's absolutely the next step that you need to take.
That absolutely is, and if I may just add to that, the $2.5 billion in deferred maintenance, those are facilities that are no longer being used, but what we're doing is maintaining them in a safe and acceptable manner. So the quicker we can level those or get rid of them, do the D&D on them, the better off we are as taxpayers. And I'll give you one other example. In our Albuquerque complex, I just did the groundbreaking earlier this summer, and that'll be a facility where currently we house more than 1,200 people in Albuquerque in barracks, in military barracks that were constructed in 1951. And those people still work in those. And I mean, there are, plywood on walls. This is the United States, and that's how we treat our national security infrastructure. Well, no more. And we've undertaken this opportunity to build a facility, and we'll put great workforce in a great facility. And hopefully that'll be done in the next 24 months, and we'll be moving 1,200 people into a new facility and a new complex in Albuquerque.
Peggy, anything to add on this?
I just would say it's a real testimony to I think it's 44,000 employees that both
Yes.
government and contractor employees that work in Lisa's organization. And what amazing professionals they are, because some of them do go to work every single day. I mean, we're sitting in this beautiful building in office facilities that I don't think anybody in this room, if you had the choice, that's where you'd choose to put your office. But they do it because they're dedicated to this country and they're dedicated to the mission. Some of those buildings that are Manhattan era, you have critters coming in, you have, things most of us don't have to deal with, and they through their sheer dedication come to work every day and accomplish that mission. And it's great to see the department and actually the ingenuity, quite frankly, with some of the contractors and working with private industry to get some better facilities
Absolutely.
to move those workers into. And one just opened down at Pantex, a new office facility that we put a couple thousand workers in, and it's just a delight to see a wonderful facility that they can now come to work in, and that was privately financed, and so we're looking at all those avenues for how we can help the department. And I would say, in addition, years ago when we first when Bechtel first became involved with the operation of the Y-12 site, and we're lucky enough to have congressional representation come to visit us, we started taking them on what was called the ugly tour. And so, typically when VIPs come to visit your site, you want to show off all the great things that you're doing. And we realized that in order to get the funding that was necessary to upgrade these facilities, we had to start showing them the really yuck stuff, and it has worked because they have the same feeling and emotion about it, about
Sure.
The facilities that we should be providing our workers, and they have been funding those upgrades. So,
Looking ahead a bit more, talking about regional impacts of some of these issues, gigantic supercomputers, these new facilities that are going to be using vast amounts of electricity, you're really trying to, I'm sure, look to the future of how you're going to respond to greater needs in realms that weren't even there 75 years ago. How is the planning going for those kinds of necessities?
Well, obviously, it's very complex with the huge amounts of electricity that supercomputers operate with. As many of you may have heard, the United States was just named, has the number 1 and number 2 spots in the high-performance computers in the world. The first is the first is Summit at Oak Ridge National Laboratory, and number 2 is Sierra at Lawrence Livermore National Laboratory. Sierra's running, just in terms of power consumption, Sierra's running 5 times the amount of data and number crunching and high performance computing as its previous, as the predecessor did, Sequoia, but it's using 1/5 the amount of power, electricity. We're working very closely in public-private partnerships to figure out ways of being more energy efficient. And as we are on the cusp of exascale, we've just funded the start of our next 2 exascale projects, one at Oak Ridge National Laboratory and one at Lawrence Livermore. Lawrence Livermore will be dedicated to the national security mission and will be ready to operate in 2022. But we're working to make sure that we can do whatever we possibly can to minimize energy consumption, because obviously it takes huge amounts of electricity to cool them. But we were working, like I said, with public-private partnerships and within our national laboratory complex to come up with innovative ways to reduce power consumption and requirements.
Other thoughts on that? No? David, maybe you could talk a bit more about your work on the Manhattan Project National Historical Park and some of the historic preservation side of this as opposed to the sort of scary nuclear side of this.
Well, actually, I'm really proud of the way the department handled it, and I'll go back to, this is actually, I'm a recidivist at the department. I was there at the end of the Clinton administration and was there back again for the time that Secretary Moniz was there during the Obama administration. But when I was there back in the late 90s with T.J. Glauthier and others, the National Historic Preservation Act was kicking in, and one of the requirements of the act is that you have to do a historic preservation assessment on any federal facilities that's 50 years old or older, and you plan to take it down. And the department had literally thousands of them. And we were unbelievably fortunate at the time to have a historian named Skip Gosling. And one of the things that Skip did is Skip, instead of thinking about it facility by facility, thought about it from the standpoint of understanding what the Manhattan Project was in its entirety, and asked the question, how do we preserve the history of the Manhattan Project? And together we went through and identified, Skip identified what he said, can we label them, quote, signature sites of the Manhattan Project? Can we, and it was the B reactor, it was the X-10, it was, it was the V site at Los Alamos that unfortunately was burned down in the fire. But it was, probably about 10 to 15 different sites. And I remember going through the B reactor when it was musty and there was mold and it was, no one could go through, et cetera. And he said, look, if we save these collectively, we will have selectively been able to save the history of the Manhattan Project. And at the same time, we can do a historic preservation assessment on a reactor that can be cocooned to take it down and say, no, we're saving this. And if we save these, then we can take down the other facilities without meeting the intent of the law. We did one other thing, and is that we there's a very small federal entity called the Advisory Council on Historic Preservation.
Headquartered in this building.
Headquartered in this building,
Really?
Still run by John Fowler.
Yes.
An antique in his own way. And we basically found some funds, and we hired the Advisory Council on Historic Preservation, and we said, get some experts in historic preservation and tell us what you think. And they put together a group of a dozen people who were federal historians, and there's such a thing as public historians that really specialize in this. And they went around to all of the sites, and they not only looked at the sites, but they also did something really, really important, which is they met with the communities, and they talked to the people in each of the communities, because the communities are incredibly proud of their history. And they looked at the plan of what we plan to save and said, that's the thing to do. And so back at the end of the 90s, we signed and designated, and we made up the idea. These are signature sites of the Manhattan Project. And that preserved that core and of what 20 years later, after a lot of people really said, hey, look, this has meaning beyond just, we have to figure out how to get the public into this. And there was a group of people, Cindy Kelly, some of the folks here in this department, some of the folks here, a lot of the members of the public, a lot of the community went to Congress and said, hey, can we make this a national park? And in 2015, I believe it was, they seemed to have leverage on the one member who had been resistant, and it got included and was designated as a national historical, the Manhattan Project National Historical Park was designated. And what it set about it said that the Department of Energy, because all of the facilities are still DOE facilities, they're never going to be turned over to the national park. They're sitting in the middle of the properties that the department currently owns. And it's the department's job to maintain them and to assure the security and the safety of those facilities. They said, work with the National Park Service and come up with a plan. And we designated at DOE a group from across the complex, and a small group, and said, you're the group that's going to work with the National Park Service and figure out which facilities are in and which facilities are not in the national park. What can we really do? How do we put together a plan for this? And I believe it was November 11th that Secretary of Interior and Secretary Moniz together signed the document that officially established the Manhattan Project National Park. And it's now in the development stage. It takes about 2 to 5 years for a park to actually get up and running. They do a park plan. That park plan is subject to comment and public comment and input. They're kind of at the point where they're figuring out what their themes are going to be, how they're going to operate, et cetera. So the park is getting up to speed and being established. And fortunately, while it is, some of the facilities are still open and available to the public. So I would say, I think the department really is and should be very proud of the way in which it managed this concept of having a major historical asset and involving the advisory council, and I think we did it right. And I'm really pleased that the Congress established the national park, and I'm sure that a lot of people will come and see it in the future. And people who do, I think one of my favorite things to do is to walk into the B reactor with someone who's never been there and watch them just open their mouth and go, oh my. And that's the reaction everybody has, is I can't believe they built this thing in 11 months. It had never been built before, and they understand the scale and the challenge of it.
So I can recommend it too. If you go out to Washington State, take a tour. The other amazing thing about the facility is some of the docents, because they were actually workers in the facility at the time that it was operating. So they're pretty interesting individuals to talk to.
I can attest to that as well. In fact, for those of you who've seen the exhibition, if you may have noticed something subtle, the color, the background color, the green, was inspired directly by the color of the equipment at the B reactor. It was that sort of universal mid-20th century government green that was on desks and everything. And it was, so that's exactly where that came from.
I'm not sure that it's quite mid-20th century because I still see a lot of it.
That does make it sound somehow mid-century
It
modern.
does.
But, let's talk a bit about a more human component of this. We've obviously lost generations of people who were in the Manhattan Project directly, but also now people who came immediately after that, and we're sort of in the key phase of converting all of these operations to a Cold War format, and then eventually kind of moving away from that. From a human resources side, what sort of things are underway now to maintain the level of knowledge, to improve upon that, again, while protecting the safety of all these people involved?
Well, I might take a stab at that. Our workforce in the NNSA alone is 44,000 people, as Peggy alluded to before. That's 44,000 people at 8 labs, plants, and sites. We have a challenge ahead of us. These are the people, the quiet professionals that we see day in and day out. Many of you are here in the audience this evening, whether you're at DOE headquarters or a field office or a lab plant or site. These are people that are basically our silent heroes that maintain our nuclear deterrent, that power the nuclear navy, that reduce global dangers, nuclear dangers, that do all these wonderful things. And they're your neighbors, they're your cousins, they're your brothers, they're your sisters, they're your wives and husbands. And every single day, the people that I meet, I am just amazed. I hope I will have the opportunity during my tenure to be able to shake every single person's hands, because it's all about the people. Now, that said, we have a real challenge, because right now we're busier than we have been since the end of the Cold War. We've got 4 modernization programs going on right now. We've got other opportunities, as I like to say, rather than challenges ahead of us about what we're going to do in many of these Cold War era buildings. We're also coming upon a real reality here that in the next 5 years, we're going to hit the bathtub curve, as everybody talks about it, where in the next 5 years, more than 40% of our workforce will be retirement eligible. So because we are so busy and we have this other challenge about our workforce and the challenges in the United States that not a lot of students are going into STEM, science, technology, engineering, and math, that we need to do something about raising people that are working the best and the brightest, as we talk about, whether they're scientists or engineers, technicians, and the workforce throughout our entire complex. So we have taken on a strategy to look across the entire NNSA, not as individual 8 sites and the headquarters and field offices, but as an entire complex about trying to bring in a new workforce, if you will, or engage, because we need to maintain the expertise that's already institutionalized in our facilities and labs, plants, and sites that are doing the work, and train the next generation. In addition to that, we have to also worry about the next 2 to 5 to 7 years where we'll have the challenges of the retiring workforce and get them onto speed so that hopefully in 20 or 30 or 40 years, the people that we're hiring now will still be in it like I was. I started out my career, as you mentioned, at Lawrence Livermore National Laboratory. I'm back again. But let me just say something else about people. I had an opportunity in May when I visited Y12. Ray Smith, who's the historian out at Oak Ridge, was just a wonderful gentleman. I had the honor and the opportunity to have coffee with a delightful lady named Ruth Huddleston. Ruth is one of the Calyutron girls, the original Calyutron girls. And I got to tell you, just when I say it, I get goosebumps. It was such an amazing thing. And she was talking a little bit about, her experiences. And I said, well, actually, how did your family find out that she said, my family never knew. I worked at Oak Ridge, and what I did at Y12, I came home, and I said, well, how did they find out? She said, well, in about the 90s, one of my granddaughters was talking about, and they lived in Knoxville, I'm doing a project on Oak Ridge, and she said, oh, I can help you with that. And her whole family, including her son, said, how would you know? And she said, well, that's where I worked. And so she started talking about all the things she did. And he said, why didn't you ever tell us about this? And she said, because I was told not to. So, I mean, and it's just that security, you just hear that. And here's this 90-plus-year-old lady she's just this vim and vigor and just excited about what she's doing. And she was excited telling me about it as the day you could tell that she was one of those original Calyutron girls you see on the front of the book, turning the knobs. And she was telling some funny stories about that, too, and about keeping the physicists and the scientists away from the knobs and letting the girls do their work. Because we know what physicists do when they get their hands on something. They want to make it better. So, but in a more serious note, we really do have challenges ahead of us, not only in DOE and NNSA, but across the rest of the national security infrastructure, whether it's in DOD and other parts of our workforce, really trying to do what we can, but we have a good strategy ahead of us, and working with our workforce made up of wonderful people from Bechtel and other of our labs, plants, and sites that are partners. I know we're up to the challenge, and I know we're going to make it.
Let me speak a little bit to this. You spoke to the NNSA workforce, and I'll warn Peggy, I'm going to talk to about the federal workforce and turn it over to her to talk a little bit about what it's like in the capacity of Bechtel and contractors to deal with it. I used to give a speech I called the 30/4 speech, and the 30 was the number of people who would be gone at the Environmental Management Office within 5 years, not retirement eligible, gone. And that was, for the most part, the senior people. You know what the 4 was? The 4 was the percentage of our workforce 30 and under. And 2 years earlier, it had been 10%. It had been 8% and 10%. And one of the things that the federal government needs to figure out how to do is to hire. And it's not doing it very well right now. It is not an attractive place to work. I think the way in which the public debate basically discourages people or sort of disparages the role of the federal government and what it does has discouraged the real capable people from our younger crowd to go into government. And I think one of the things that has to change at some point or other is that government service has to come back to be an honorable, respected thing that people want to do instead of going off to some financial firm in New York City and make a pile of money and all that stuff. I think we need to change the perception of what federal service is, and I think that's one of the major challenges. DOE has 13,000 federal employees. It has 100,000 contractors, and that's the challenge. So I warned you, Peggy.
Yeah, it's a big concern. Just having been at Livermore last week, it's a multi-pronged strategy. It looks at we invite retirees to come back. They actually come back and contribute on a non-paid basis just because they love the laboratory work and they want to impart their knowledge. It's about creating a great place to work so that we can recruit people and that they want to stay at the laboratories. I mean, these are incredible minds that work at these institutions. And in a place like Livermore, they have some pretty big, stiff competition in the Bay Area with the Googles, with with people who can get, organizations that will offer them stock options. So really, the only choice is to be a fantastic place to work and give them that sense of mission. But there are lots of recruitment programs in terms of, now we're even targeting people at the high school level to try and get them hooked into the laboratory system so that when they finish college or grad school, they want to come to work at the labs. So I think it's something on all of our minds because it's real and it's critical, and we're doing a lot of things. They're doing some amazing things at Livermore, quite frankly, in the HR arena in terms of creating a diverse and inclusive workforce that people want to go and work there.
I would like to, it's one of these open-ended questions a lot of times people hate, but is there some particular thing, some tidbit of it could be a factoid or just some story, but when you talk about this sort of thing, people jump to so many conclusions about what it is, and I'll tell you frankly, as I'm trained as an architect. I have an architecture degree, but I was always a bit of a math and science nerd in high school, so I always sort of took to a lot of this stuff. As some people know, my husband grew up in Oak Ridge, Tennessee. His father was a nuclear physicist at ORNL. And so I started having these conversations decades ago with him about just the fascinating stuff of this. And purely from kind of an academic standpoint, there are just so many incredible stories behind just the ingenuity of this, the coincidences, the things that were necessary and for all this to happen. Are there any stories that come to your mind? Again, it could be factoids, but things that you wish people understood about this line of work or about these issues that might change their impression of the whole idea of, when we talk about nuclear weapons stockpile, the nuclear security complex. These are intimidating kinds of things. How do you humanize that for people?
You want to go?
Oh, go ahead.
I'll choose an example that's really not in the nuclear science world, but a lot of people don't understand that DOE spends about $5 billion a year on basic science. And one of the things it does is it provides basic science tools that are too big for any company to use, any company to acquire, any scientist to be able to do. And across DOE's complex, I looked the statistics up. It has more than 32,000 individual users of DOE's science. It's the accelerators, it's the light sources, it's the computing capability. And one of the favorite things I tell people is that every major drug company in the world is in there. And they're in there because the light sources and the tools that they have enable them to look at viruses and proteins and things at a level that you simply can't. And one of the examples I tell people, and this is, I'm a history major, I'm not a science major, and I took the easy way out, but someone explained to me very simply, one of the discoveries that happened at the Stanford lab by Abbott is that they found the inhibitor for the HIV virus. And simply put, if you think of HIV as, think of it as, the virus think of it as like the one side of an electric plug. And it had only so many ways it can interact with the outside world. And using the tools that DOE had, they were able to look at the virus in such a way that they could figure out what those interactors were, and they were able to design drugs that actually filled the other side of that. And that's what an inhibitor is. It's an inhibitor. You still have the HIV virus, but they've designed a drug because they could see it at a level that you previously couldn't see it, that filled its ability to interact and to replicate. And those are the sorts of things that happen at the laboratories. And when I took a look at the sites today, I discovered they've got another inhibitor, I think it's the BFA, something BRFA or something like that, that now is doing the same thing for melanoma and for other types of cancers. And so if I were to sort of think about it, and you talk about what's the future, what's the 75 years going to hold, I always think about DOE in terms of the future, not just in terms of the nuclear science and all that stuff, but some of the providing basic tools that are going to be what our future is, how we begin to solve really difficult diseases, and frankly, how we build an economy in this country that's the higher edge of the economy. That's where the U.S. is going to succeed by doing the things that are at the upper edge of the challenges. And so I think of DOE that way, and that's sort of one example of what I think of when I think of DOE and its unusual things that people don't usually understand about the department.
So two things come to mind. First are the multi-user facilities that are available at the national laboratories, so people from all over the world can come into those facilities and conduct experiments. And it is very much tied to the economy. If you compare the U.S. and the U.S. economy, our ability in this country to invent, to develop, is a huge driver for our economy, why we do better than other countries. And the national laboratories are a part of that. Not only the ability to come in and use the facilities, but some of the technology that's developed at the national labs, then they have programs to transfer it out to industry, to give them the cutting edge. Some other things that probably almost anybody in the room can relate to, touring the high explosives facility at Livermore, they work on trying to figure out how, we're living in a world where terrorism is a reality. They try to figure out how a bad actor could make something that explodes from common ingredients found in your kitchen. And they use that to inform the Department of Homeland Security and the TSA about what to look for. So when you get swiped down at the airport in that machine, the national laboratories are informing our security agencies to help keep you safe when you fly.
Anything come to your mind?
Yeah, actually, it goes back to the point I've been trying to make about people. It's all about the people. Most recently, I was out at Savannah River site, and I was talking to one of our technicians in the workforce, and I asked him. He was doing this one procedure, and he was showing me how he did it, and I said, "Well, how many of you are trained?" I said, "How long does it take to train?" He said 3 years for this position, and he was working in the hot cells, so he's working remotely with the remote handlers. And he says it takes about 3 years. And I said, "Well, how many people are trained at Savannah River to do this job?" He said 4. And I said, "Do you realize how important your job is?" And he said, I'm just a technician. I'm just doing this job every day." And I said, "You know what? Well, if the 4 of you went away today, your work to support the tritium, which was a nuclear deterrent, which is the reason we're all here and we have wonderful lives and we live in the most freedom-loving country on the planet, everything would stop, because your position of the 44,000 people in our workforce is so important. So every single person has to recognize the important role that you play individually and collectively. And so to me, it's all about the people. We can have the best buildings, and with all due respect to the architect here at stage here, we can have the best buildings, leads, everything else, but without the infrastructure, the people, we're nothing. And so it's all the people here, it's all the people out in our labs, plants, and sites at our headquarters and our field offices that make us the great nation that we are and that are protecting our national security. And so everything we do, it's all about the people. And so when I talk to technicians, and I talk to people, "Oh, in my job, I'm just a technician, anybody can do it." No, not really. You told me it took 3 years to train somebody, and there are only 4 of you in our nation that can do this job. And so, that to me is a huge, that to me is the best pat on the back, the best accolade we can have in our national security field. And I know it's the same in the Office of Science and the other laboratories and plants and sites throughout the Department of Energy, and for that matter, throughout the entire U.S. government. But it really touches me when I have a chance to meet people, and it's really about the people.
Well, with that, I feel like straight out of late night show. I've gotten these nice big cards here. We've got quite a few. And since we do have a hard stop at 8 o'clock because one of our panelists has to go off on an airplane, I'll dive into this. If a group were to meet 75 years from today to discuss the impact of the secret cities as we are today, what do you hope they would discuss about that impact? I guess the follow-up question is it fundamentally different from what we hope they'd talk about today, that we're talking about today, or is there something that's different now? I mean, I would think some of us might think that we would hope that the political environment of nuclear weapons had changed, but maybe it's hard to know what that's going to be 75 years from now.
guess I would say that I would hope that they would continue to innovate at the rapidity at which we've been seeing over the last 75 years, that we have that kind of innovation. And yes, you know, I'm the first person to stand up and said, I wish this world were, you know, nuclear free. But as long as we have one nuclear weapon on this planet, it has to be safe, secure, and reliable. We have to make sure that that's it. But we will work towards that, and we will work to continue to maintain our nuclear deterrent. But I'm hoping for the same kind of innovation. You know, we talk about the site formerly known as Yucca Mountain, or whatever, or soon to be known again, whatever it is, and that's not in my area of responsibility. Thank you. And so this is on tape, isn't it? Oh boy.
Hey, I'm gone. You can.
But in all seriousness, I think that the stupendous amounts of science and engineering where we've come in the last 75 years, I am confident that the next generation of scientists and engineers will be able to figure out what to do with nuclear waste and with all the other hazardous and toxic materials and all the other challenges we have throughout the world. And so that's what I would like to see. And hopefully they'll say, boy, look at the level and extent of science and innovation that we've undertaken from the past 75 years.
I hope the cleanup's done, and that they've managed to find ways to do it faster than the 40 or 50 years that we're talking about. And I know that the folks that are there now have begun to put a little more money into the research of how do we do it faster and how do we do it better, and that's something that has to happen. And I hope the sites have actually turned back to the communities from which they were taken, and there are tribes that have at many of these places that considered them their homelands, and they're very valuable to them. And I hope that we're able to restore a lot of the, DOE collectively has a land mass equal to larger than Delaware and Rhode Island combined. I hope that we've been able to give some of that back to the public and turn it back to public uses, and that WTP not only finished its job, but we tore it down. And that if we continue to spend $3 billion a year, I hope it's at Hanford, I hope it's on PNNL, and we're doing the types of things that we've talked about that can happen, that build the community and the world and the science.
Well, I certainly hope they would be talking about the fact that this mission has succeeded for 150 years, that our country is safe and secure.
Yeah, we're still there. That's a good sign of success.
I mean, clearly, in terms of the geopolitical situation, when you think, and this clearly was pointed out in the nuclear posture review, but at the time of the previous nuclear posture review, the U.S. was in discussions with Russia about joining NATO. That's how different the relationship was between the U.S. and Russia. So, the influence of the leaders who come to our country, to all the countries, makes a big difference in terms of the posture and the philosophy. And we're dealing with having done a lot of work in the former Soviet Union to demilitarize. And to now see this rising back up, and for them being so aggressively moving back into, an acquisition stance, 75 years is a long time, and a lot of changes will come and go in the geopolitical situation. And so I hope that group will say, we made the right decisions. We kept our country safe. We allowed the economy to flourish. And it's still a great nation where people want to live.
I just visited Los Alamos Museum and was struck by the social structure that existed there. It truly was a secret city. Can you talk a little bit about the way and how that city evolved, the people, and do we know anything about health issues or whatever there is, or whatever? Is there a book about the lives and workers there? I can talk a bit about the last question. There's several books that touch on that. Forgive me, I don't know titles offhand. In preparation for this exhibition, I think I read something on the order of 60 books and about 15,000 online pages, so they don't always come to the top of my mind, but there are several books, sort of memoirs of people talking about their experiences in each of the cities, and there's definitely a couple for Los Alamos. In addition, the Atomic Heritage Foundation, which has been mentioned before,
these things very quickly, as we all know, not like we did them during the Manhattan Project where we built a reactor in 11 months. This is many, many years, decades of building these kinds of highly hazardous operations or conducting these operations in a safe and secure manner in these facilities. So we have a very tough road ahead of us, but we're confident we're going to be able to do that. So we'll have a dual-pronged approach, because right now we have one location in the United States that maintains our nuclear weapons and our stockpile, and that's at Los Alamos. And if there's a major event there, we'll have no capability in the United States to maintain our nuclear weapons stockpile. So therefore, we've decided to start a two-pronged strategy and approach, and Congress has been very helpful with this. It's spelled out in the Nuclear Posture Review. That we need to have a resilient infrastructure in the Department of Energy and NNSA, and so that's what we're undertaking, and we're going full force on that right now. And that's at the Savannah River site, which is another one of our facilities that DuPont ran starting in the early 1950s. Also supportive, built many reactors there, did plutonium production. Still maintain facilities there. It's about, I think, 351 square miles. We do a lot of environmental restoration and cleanup, but it also contributes to our national security.
This is a compound question, but I think the gist is, you mentioned the 44,000 people. There's a question about how many of those are federal scientists, contractors, guards, cleaning crews. Sort of how does that all divvy up?
Okay, well, I'll take that one too. So 44,000 people in our workforce in the National Nuclear Security Administration. I try to avoid calling them contractors and federal employees, because we're a team. We're a team made up of headquarters, field, labs, plants, and sites, and we're all working on the same mission, and we're also executing the same mission to get to the same goal. So that said, we are capped at 1,690 federal employees at our headquarters, and our field offices are 7 field offices. We have one site office called the NNSA Production Office, and that splits between Oak Ridge and Pantex in Amarillo, Texas. So that's why we have 7 of those and 8 sites. We are going to be blowing through that cap this year, and so I have to notify Congress shortly, because of course, like I said, we're busier than we have been since the end of the Cold War, and we need the appropriate amount of oversight so that our labs, plants, and sites can execute our very important national security missions. We have about 38,000, if you will, members of our labs, plants, and sites, and then the delta there of about 5,700 or so run our naval reactors program. And as I mentioned, of the 3 core missions in NNSA, one is to maintain the nuclear deterrent. The second is to provide the reactors and the nuclear fuel for powering our United States Navy, so our submarines and our aircraft carriers. And our third is reducing global danger, or nuclear dangers. So about 5,700 people in our naval propulsion or nuclear reactors program, naval reactors program.
Another person raises a question that I was sort of going to get at. It's fascinating to me that, again, coming up at this from an architecture background, how many of the names of the firms that are involved with cleanup are names that also are associated with sort of more benign design and building industry sorts of things. Bechtel, there are a number of companies that you see their names, and a lot of architects would think of them as contractors building office buildings and schools and dams and infrastructure and so on. So maybe you could talk a bit more about the role of Bechtel now, especially in the cities today and moving forward. What kind of role it's playing beyond just sort of the typical engineering and contracting firm?
Specifically with respect to the secret cities?
Yeah,
or?
because it's a bit of a different thing than, say, building a bridge or a dam.
Yeah, I would say that we're not typically involved in what I would consider to be, we would call it tilt-up construction of office buildings. It's not really something that we do. Right. Where we would undertake that is as part of let's say a much bigger program, building a city in Saudi Arabia, something like that. Because really our focus is on more complex process facilities, and so outside of our direct involvement working for the Department of Energy in those communities, we're typically not building something in Oak Ridge or Hanford. We just aren't. So, conceivably, if an oil and gas customer wanted to put a facility on the Columbia River, that's probably something that we would take a look at, but I would consider that to be a pretty unlikely scenario to unfold. I do think that certainly with respect to Hanford, who was, as a community, the Tri-Cities, Richland in particular, the Tri-Cities is 3 incorporated towns, Kennewick, Richland, and Pasco. The community was always very heavily dependent on the Department of Energy because of such a large employee population. And I would say over the last decade, it's really begun to diversify with the wine industry, with food processing, and that's a great thing. This ties back into people, because the more diverse the community, the better the housing opportunities, the job opportunities for the spouses who don't work for the Department of Energy. That's all a very, very healthy thing for both the department's mission and for those communities. So we would be supportive of anything that led to a better community for our workers to live in, because that helps us attract the best and the brightest.
Mm-hmm.
People want to live in a good community.
See, if I was thinking that question in maybe a little different way when you're mentioning the design and construct companies. We are very fortunate because we have opportunities to work with companies like Bechtel, Fluor, AECOM, the University of California, all the ones that run CNS, Bechtel, run UT Bechtel Consortium. We're very fortunate that we have the opportunity when we put out requests for proposals to do these big construction projects, whether it's a UPF facility, $6.5 billion at Y12, or our plan for repurposing the MOX facility at Savannah River site, that we're very fortunate that these companies will undertake these projects and be able to assume responsibility for these projects, because these are, again, they're highly hazardous, potentially highly hazardous operations, and they're assuming some risk as well. But we're very fortunate that we have them, that they're capable to do this kind of work. So.
Another question, are they going to consider accommodating incubation for new energy businesses on all these sites? I think we've kind of touched on this a little bit, but there's a lot of non-nuclear and sort of new research going on into different applications, different technologies. Maybe you could talk a bit more about that.
Well, let me, and actually T.J. Glouthier is here, who was chair of a commission on the future of the national labs, and one of the key elements of the commission's recommendations was how can we further enhance, and I use the word further, enhance the interaction between the laboratories and small businesses, between the laboratories and researchers and academics, et cetera. And one of the things you have, for example, we haven't talked about Sandia, but Sandia and a number of the labs, and I think actually Oak Ridge, are building buildings just outside the fence, in which are designed for the laboratories to be able to interact with businesses and companies and researchers who want to take advantage of and interact with the scientists who are there. And I'll go back to a statistic I previously cited, which is with the Office of Science, there are over 32,000 users each year, at least that's a 2015 statistic, that come in and utilize DOE facilities, and they're designed for that purpose. And literally a couple hundred small businesses that, and it's an opportunity not just to use a tool, because there are groups of scientists there who help those businesses and help those researchers with their projects. And so I think you have this built-in incubator, and I know one of the recommendations that the commission made and really trumpeted was that a key future challenge for the laboratory is to really extend that even more, because that is you asked, what are we going to be talking about in 75 years? I really do think that the combination of the laboratories and the interaction with the national security force, because the national security mission brings with it scientific challenges. Nanotechnology comes out of there. High performance computing comes out of that. The number of ways in which the United States is a world leader, a lot of it comes from some of the scientific research that's being done in the context of the national security mission. That in turn, through the laboratories, not just the national security laboratories, but the other laboratories, becomes a way for it to spread throughout not just our economy, but to work with companies from around the world to do it. So, I don't know.
We're about to wrap up as we're getting close to the 8 o'clock hour, so I'll just finish we've talked a bit about this again, but are there just things going on today that really we haven't talked about in these sites? Most people think of these still in very much in Manhattan Project terms. They think of nuclear weapons, et cetera. A bit more about some of these, picking up on what you said, some of these non-weapons scientific developments that are out of these sites. For instance, the millimeter wave technology coming out of Hanford, the Mars rover that came out of Los Alamos. Yeah. Are there any sort of pet projects of yours, things that other fun aspects of the work that's being done there that people might not know about?
There's actually one that we're just doing that's just been undertaken by Los Alamos that's going to be microreactors that actually are going to probably propel us into having living condition, or being able to put together living conditions on Mars, and we'll be able to power long-term power on Mars and on the moon.
Cool.
And so we're working those programs right now, and that's undertaken from a national security lab, but we're also helping NASA be able to invent the next type of micropower reactors. We're doing other work in a lot of different areas, and as all of us have mentioned, so many of the spin-offs from the national security missions support our everyday lives and everything we do, whether it was polyester or whether it was just anything nanotechnologies and fabrics and things like that. So it's a pretty amazing thing that the contributions that we make at the national security and the energy security and science labs, it's pretty amazing, and they touch our everyday lives.
It's funny. The favorite example that a guy named Mike Telson used to be the CFO of the department used to give. He said, NASA was really proud of Tang, but it's the Department of Energy that figured out how to make concentrated orange juice. And so, but sort of one of my sort of the interesting ones, and I've never been able to get to the ground truth of this one, is that one of the things that comes out of making explosives, et cetera, is that the laboratories are the world's experts in combustion. And because they are the world's experts in combustion, they've developed some resource centers and some research centers where every major automobile company comes in order to perfect the combustion that happens inside an internal combustion engine. And it is part of what has enabled the companies. How do you now get a 2-liter 4-cylinder engine that produces the amount of power that it does with the clean and the efficiency? And a lot of that is because they have combustion models that are, I believe they're XND is my recollection, and the combustion center. And so you wouldn't imagine that automobile technology is being, the leading edge of auto technology and engines is related in part to the combustion and the combustion issues that originally started with, of all things, weapons.
So the supercomputing capability that exists at the labs, one of the things that comes to mind, the University of San Francisco, working with Livermore, is now using the supercomputer to analyze brain scans for brain trauma. So apparently getting to a brain trauma victim very quickly and assessing what the damage is crucial to making the right diagnosis and treatment. And there's a brain specialist at the University of San Francisco who's seen, hundreds and thousands of these brain scans and worked with the scientists at Livermore to develop some code that can be run very quickly, in a minute, on that supercomputer, and it gives the doctor an incredible amount of data to actually analyze the brain trauma. So I think you'd be amazed at how many of those things are happening where they're tapping into what is essentially a national security asset for the benefit of people suffering from traumatic brain injuries.
Right. So in summary, to paraphrase Matt Damon, we're going to science the heck out of this. Thank you all for joining us tonight. We really appreciate it. Thanks for coming.